All right, good morning, everybody. How you're doing today? Can anybody hear me? All right, great. All right, so today we are going to be discussing the remaining part of the reproductive system. If you remember, the last topics that we've been discussing was the folliculogenesis, oogenesis, and the uterine and menstrual cycle. If you remember the sequence of events, each month after puberty, the hypothalamus, if you remember, was releasing a hormone. We call this hormone that stimulates the anterior pituitary gland to release its gonadotropins, the gonadotropin releasing hormone, or GnRH. And if you remember, the GnRH was stimulating the anterior pituitary gland to release a hormone. We call this hormone the follicle stimulating hormone, or FSH. If you remember, the type of eggs that will be kept in the ovaries after birth, remember, we started the oogenesis by a stem cell. We call the stem cell an oogonium. The oogonium divides by a mitotic division during fetal life of females into primary oocytes, and this is the type of eggs that we have in the ovary. Primary oocytes are gonna be kept inside a follicle, and if you remember, they will be first surrounded by one layer of flat cells. So the primary oocyte, along with the one layer of flat cells that we have in here, it's what we call the primordial follicle. Each month after the release of FSH, after puberty, the primordial follicles, some of the primordial follicles on here, will become activated into primary follicles, where the follicular cells surrounding the primary oocytes are going to become cuboidal cells. And then the primary follicles will become secondary follicles, where the follicular cells won't be just one layer. I will have two or more cell layers surrounding the primary oocytes. Remember, the primary oocytes will not complete meiosis 1 until the time of ovulation. Secondary follicle, if you remember, one of those growing secondary follicles will become a mature follicle, or what we call the Griffin follicle. Each month we've got one Griffin follicle. All those growing follicles, remember, they would be releasing an ovarian hormone that we've called the estrogen. The Griffin follicle or the mature follicle gonna be releasing large amounts of estrogen, which will have a positive feedback on the hypothalamus and anterior pituitary gland, stimulating the release of GnRH, and this time it's going to be stimulating the anterior pituitary gland not only to release FSH but to release a large amount of LH. This is going to result in a sudden rise in the LH levels. We call this as the LH surge. Remember, three consequences for the LH surge. First one, you've got a completion of meiosis 1. The primary oocyte kept in this Griffin follicle will become a secondary oocyte. So I've completed the first cell division of the meiosis. Another thing is that this Griffin follicle gonna rupture, releasing the secondary oocyte, and we call the rupture and the release of the egg in here, it's the ovulation. And those follicular cells that were surrounding my primary oocytes that became a secondary oocyte will be transformed and will form the yellow body on here. This is what we call the corpus luteum. Corpus luteum is not going to be releasing estrogen like those growing follicles. Instead, it's going to be releasing another ovarian hormone. This is going to be the progesterone. And this corpus luteum, if no fertilization takes place, it's going to remain in the ovary for 14 days, and then it will degenerate. Corpus luteum, once it degenerates, you won't have any further progesterone. Remember, the progesterone released from the corpus luteum gonna have a negative feedback on the hypothalamus and the anterior pituitary gland, preventing the production of FSH. So I don't have FSH released. So during this phase where I have the corpus luteum in the ovary for 14 days, there would be no growing follicles. What was the effect of those ovarian hormones, estrogen produced from those growing follicles? And the progesterone, which is produced from the corpus luteum on the endometrial line. Remember the wall of the uterus, it was formed of 3 layers from inside out. I've got the internal lining of the uterus. We call this is the endometrium. Remember, endo on the inside, and metrio. Metrio means related to the uterus. Next layer is going to be the muscle layer, and we call this muscle layer of the uterus the myometrium. And the layers that would be surrounding the uterus from outside, remember, around is peri. So we're gonna call this is the perimetrium. Peri around, metrio is uterus. So you've got inside the uterus endometrium. The muscle layer of the uterus is the myometrium, and the layer surrounding the uterus from outside, this is going to be the perimetrium. We've seen that the endometrium is formed of two layers, if you remember. The most internal layer, this is the layer that changes its thickness corresponding to the ovarian hormonal changes, and we call this as the stratum functionalis, or the functional layer. And deeper to it, deeper to the stratum functionalis, we've got the stratum basalis, or the basal layer, that doesn't get affected by the ovarian hormonal changes. So before the growth of those follicles, the thickness of the endometrium is going to be consisting mainly of the stratum basalis. As I start to grow the follicles, releasing the estrogen will be enhancing the proliferation of the stratum basalis, for the stratum basalis to start building up the stratum functionalis, increasing the thickness, as you see on here, of the stratum functionalis. So the main thing that takes place at this point under the effect of estrogen is going to be the proliferation. So we call this phase of the menstrual cycle, it's the proliferative phase. Now the Griffin follicle has ruptured and the corpus luteum has been formed, and it will be producing progesterone. If you remember, pro precedes, and gestation means pregnancy. So this is a hormone that precedes pregnancy, progesterone. So this progesterone, what's going to be its effect on the endometrial lining? It's going to be increasing the thickness a little bit, but mainly it's going to be stimulating the glands inside the endometrium to produce their secretions. Also, it enhances the growth of the blood vessels embedded in this endometrial lining, and will engorge them, will fill them with blood. Why do I do this? Because I'm expecting a baby to be formed. So if I'm expecting a fetus to be formed, I need to prepare a suitable endometrial lining for it to get implanted in. So glands gonna be filled with secretions, blood vessels gonna be filled with blood to create a suitable environment for the fetus to be implanted, for the zygote to be implanted. What happens if there was no fertilization of the egg? So the egg didn't get penetrated by sperm, didn't get fertilized. Remember, if no sperm penetrates the secondary oocyte, would I have a mature ovum? Would there be any completion of the meiosis? No. So first thing that won't take place is that the secondary oocyte will not become a mature ovum if no penetration by sperm takes place. What else is going to happen? This corpus luteum, again, will degenerate. And as it degenerates, what's going to happen to the levels of progesterone? They will decline. Remember, the progesterone did have a negative feedback on the hypothalamus. So you didn't have FSH produced. And if you don't have FSH, this means there will be no growing follicles. And if you don't have growing follicles, you won't be producing estrogen. So at this point, what is going on in the ovary? What ovarian hormone am I releasing? If I am degenerating the corpus luteum, if I'm degenerating the corpus luteum, I have a major decline in the progesterone levels, and the progesterone was already decreasing the estrogen levels because I don't have growing follicles which are producing the estrogen. So at this point, what ovarian hormone would I have once I degenerate the corpus luteum? Once you degenerate the corpus luteum, do you have any progesterone? No, exactly. Do I have any estrogen? No. So if you don't have any ovarian hormone, you don't have neither estrogen or progesterone, what's going to happen? There will be no support for the stratum functionalis of the endometrium. Remember, in order for you to sustain the proliferation, to maintain the thickness of the endometrial lining, you're going to need to be supported by estrogen and progesterone. So what happens when I have a major decline in all ovarian hormones? The endometrial lining gonna be shedding, and I will have this menstrual blood flow. The shedding of the endometrium, remember, we call this phase of the menstrual cycles, this is the menstrual phase, which takes place between days 1 to 4. And again, this will take place only if there was no fertilization of the egg, and resulting in degeneration of the corpus luteum. So once you degenerate corpus luteum, you're going to have a decline in both progesterone, estrogen levels, which will not allow you to support the endometrial lining. And as you fail to support the endometrial lining again, this is going to be resulting in shedding of the endometrium. So we see here 3 phases of the menstrual cycle. First phase, it will last for around 4 days, starting from day 1 to day 4 of the cycle. This is what we've called the menstrual phase. By day 4, what happens? You did already have a decline in both estrogen and progesterone, and the progesterone was having a negative feedback on the hypothalamus. So who detects the decline of all ovarian hormones is going to be your hypothalamus. And as the hypothalamus detects that there is a decline in all ovarian hormones, it starts to produce GnRH. That will again stimulate the anterior pituitary gland to release FSH another time, enhancing the growth of some new primordial follicles, and another cycle starts. So after those 4 days, what's going to happen? You're going to actually be stimulating the hypothalamus to release GnRH. And as you stimulate the hypothalamus to release GnRH, you're going to stimulate the anterior pituitary gland to release FSH. And so you're going to be enhancing the proliferation of new primordial follicles from the stalk. So inside the ovary, we have a stock of primordial follicles. Each month, few of them going to be proliferating. One of them will become the mature or Griffin follicle. So those growing follicles, again, going to be releasing what ovarian hormone? Estrogen. And you see here, the estrogen will have a proliferative effect on the endometrial lining. Again, what layer, what is the name of the layer of the endometrium that I will be increasing the thickness of, that I will be proliferating? Stratum functionalis, exactly. Stratum functionalis. So we call the phase of the menstrual cycle that lasts for around 10 days, from day 4 to day 10 of the menstrual cycle. When the proliferation of the stratum functionalis is taking place, we call it the proliferative phase. Again, what happens in the proliferative phase? I'm stimulating the stratum functionalis to build up vessels, to build up glands, and the estrogen actually going to be adding receptors for the progesterone. Once it gets released to be able to conduct its action, stimulating the glands to enhance them to release their secretions. So I'm adding receptors on the glandular cells for the progesterone to make them ready to respond to the progesterone. So proliferative phase. This is gonna last between day 4 of the cycle to day 10 of the, to day 14 of the cycle. Sorry, to day 14 of the cycle, around 10 days. What happens for this growing follicle? And again, this mature follicle gonna be releasing large amounts of estrogen, which will have a positive feedback on my pituitary gland, enhancing the pituitary gland, this time to release LH. And this sudden rise of LH is what we've called the LH surge. And we've seen the effects on here: maturation of primary into secondary oocyte, ovulation, and corpus luteum formation. What will be the effect of the corpus luteum? It's going to be producing progesterone for 14 days if no fertilization takes place. This progesterone going to be enhancing the glandular secretions, engorging the blood vessels with blood, and that's why we call this phase of the menstrual cycle, this is the secretory phase, in which I'm enhancing the glands to release their secretions. This is a constant phase. So some females will have their cycle for 28 days. Some of them will have for 30 days. Some of them will have for 27. Some of them will have it for example, will have their cycle for 32 days, 33 days, and so on. So the secretory phase is the constant phase. It's going to be 14 days in all females. What might be variable is the proliferative phase or the menstrual phase. So which one takes place first? Proliferation of the endometrium or shedding of the endometrium? What do you think? Which one takes place first? So on the very first menstrual cycle, which one should have taken place first? The proliferation of the endometrium or the shedding of the endometrium? What do you think? Got two responses here, waiting for more. Proliferation. Proliferation takes place first. So, yes, exactly. So you can't break down something that you don't have, right? So you need to build up and then break down. So proliferation is definitely taking place before the shedding of the endometrium. So why would I start counting the cycle starting from the menstrual phase? I know it's a cycle, so everything happens in a circular pattern. So it's a cycle. So if you started at this point, you're definitely going to end up at this point again. But when I start counting, why I don't start from proliferation? So the first day of the proliferation, this is going to be day 1 for me. Why do I start from the menstrual cycle, where the shedding of the endometrium takes place? Starting sign. So actually, this is the end of the cycle. The menses here is the end of the cycles. This is the end of each cycle. So each time, each month, I have a proliferation, then I have a secretory phase, then I have shedding of the endometrium. So this is the end of the cycle each time. Why am I starting counting from day 1 from the menstrual phase of the cycle? This is the first sign that you can see, exactly. This is the first thing that you can see. Yes, definitely there will be proliferation, secretion going inside, but I can't see any of this. The thing I can see is the blood dropping. So for the first blood drop, it's gonna be day 1 of the cycle. This is something that I can mark. Although it takes place at the end, it takes place at the end of the cycle, definitely, because you need to proliferate the endometrium before you break it down. But this is the first thing I can see. Exactly. Does this make sense? Any questions? All right, so let's read this part from your slides. Again, this is going to be our essay question for our last lab exam, which is going to start this Tuesday. This is going to be the essay question for this lab exam. All right, so if you want to write it down, you can write it down in the same way it's presented on the PowerPoint slides. So you can first describe the development of the follicles, follicular development. So you're gonna say I have a primordial follicle that will become a primary follicle, where the primary oocyte going to be surrounded by cuboidal to columnar cells. This primordial follicle will become a secondary follicle, where two or more layers of the follicular or granulosa cells going to be surrounding the primary oocyte. And this secondary follicle will become the Graffian or mature follicle, where I have the granulosa cells start to coalesce together, forming a space filled with fluid, and this space is what we've called the antrum, central antrum. Ovulation then takes place, where I have ejection of the egg outside of the follicular cells, and the remaining granulosa cells will be transformed into a corpus luteum. This is going to be the follicular stages of the development of the follicles. See on here, you have primordial follicles that will become primary follicles, then secondary follicles, then the Graffian follicle on here, where I have the central antrum. If you notice on here, the ovulated egg is still going to have some granulosa cells surrounding it. And they would be forming a radiating crown. So we call this is the corona radiata. Corona radiata because it simply looks like a radiating crown around the ovulated egg. And those are the remaining granulosa cells that are still surrounding the ovulated egg. We call again, this is the corona radiata. Then those granulosa cells will become the corpus luteum that will degenerate if no fertilization takes place within 14 days. All right, so this diagram is going to be a 4 stars diagram here. What is the type of egg that I have in here? This one on here. This is 1. And what is the type of eggs that I have in here? This is 2. Mentions the type of the egg for 1 and 2. What do you think? Anybody still here? So I'm asking about the type of egg. Egg. What egg did you have in here inside those follicles? primary oocyte. So number 2 is a primary oocyte. By the time of ovulation, why ovulation did take place again? It was an effect of the LH surge. And what was another effect of the LH surge that caused the ovulation to take place? Is the maturation of the primary oocyte into a secondary oocyte. So number 1 is going to be secondary oocyte. Is this clear? Is this clear? So when I ask about the egg is the gamete. The egg is surrounded by the granulosa cells and all together is called a follicle. The follicle is not the gamete. The gamete is the egg here at the center. Is this clear? Clear for everybody? Oviducts. So after the ovulation, what's going to happen to this ovulated egg? Remember, we've got those finger-like projections coming out from the fallopian tube or the uterine tube. Do you remember what did we call those finger-like projections? Those are the fimbriae. And the movement of those finger-like projections will create currents that will allow the egg to be picked up to the inside of the fallopian tube. Remember the entrance of the fallopian tube on here, this distal part at the entrance is going to be, you're getting in, we call this is the infundibulum. And remember, this ovulated egg gonna be moving to a wide part in the fallopian tube, and this wide part in the fallopian tube is what we call the ampulla. And the ampulla of the fallopian tube is the site or normal site of the fertilization of the egg. This is where the egg gonna meet the sperm. In the ampulla of the fallopian tube. If there was fertilization of the egg, what's gonna happen? This fertilized egg needs to be conducted to the endometrial cavity. And remember, it is ready for implantation to take place. We have increased the thickness of the endometrial lining. We've built up glands. We did build up blood vessels. We engorged them. We filled them with blood. This fertilized egg will be moving by the currents formed by the cilia of the of the epithelial lining of the tube. And remember, the junction here between the fallopian tube and the endometrial cavity is what we call the isthmus. So again, what is the normal site for fertilization? It's the ampulla. Uterine wall, as we've mentioned many times, we have three layers. Perimetrium, this is the outer serous layer. Then we have the smooth muscle layer, it's the myometrium, and the internal lining of the uterus, this is the endometrium, which is the mucosal line. The endometrium has two layers. The basal layer, which is unresponsive to the ovarian hormones, and its main function is to form new functionalis. Stratum functionalis is the one that responds to the ovarian hormonal changes and is the one that sheds whenever they decline. Oogenesis, remember, we started by a stem cell. This is the oogonium. Oogonia is a diploid cell. It's going to be performing a mitotic division. This will allow them to form primary oocytes. And remember, this takes place only during fetal life. Primary oocytes will begin the meiosis, but they will be arrested in prophase 1. Until when? Until puberty. Each month after puberty, few of the primary oocytes will become activated, and one is selected each month to complete meiosis 1. The one that will be located again in the dominant follicle, the mature follicle. This results once you are at the mid-cycle, you've got the LH surge. This primary oocyte will complete meiosis 1 and will be forming a first polar body to reduce the number of chromosomes. Remember, 2N cell means what? Means I have a complete set of books. Having N chromosomes, this means I have half set of chromosomes. So this cell division, I did have one replication of the DNA. So this means I have two copies. Let me write this down clearly. Here, remember what this means because this gets a lot of you confused. This is my diploid stem cells that I'm starting with, which is the oogonium that will pass through an S phase before its division. This means what for you? This means it has a complete set of genetic information. It has 46 chromosomes. The meiosis 1 will allow this cell to divide. And remember, this cell before division, it did replicate its genetic material. So this means what? This means that it has two copies of how many sets? One complete set. So in meiosis 1, what am I doing? I won't be separating the two copies from one another. Instead, I will be splitting this complete set into two half sets. But each of the daughter cells has two copies of the half set they are receiving. So the cells that I am producing are going to contain only half of the genetic information. They are haploid cells. So in this example here, this is a primary oocyte. The primary oocyte completes meiosis 1. Again, what was the triggering factor for this cell to complete meiosis 1 was the activation first by the FSH, and what allows it to complete the first phase of the cell division is going to be, or the first cell division of the meiosis is going to be the LH surge that takes place on day 14. This LH surge results in maturation of the primary oocyte into a secondary oocyte. So the secondary oocyte has what? Has two copies of half the genetic information. So what's going to happen to the other cell? Do I need this other cell? I don't need another cell, actually. So I don't want to have 4 eggs produced. So what's going to happen? This cell will divide into a secondary oocyte and a polar body that has 2 copies of the half set of the genetic material. Doesn't play any role in here normally. This is the polar body. We call this is the first polar body. First polar body. This is the first ones that we're gonna be producing. What's gonna happen to this secondary oocyte? It waits until it gets penetrated by sperm. If it got penetrated by a sperm, so now it's time for it to complete the second cell division. And again, why do I need to complete the second cell division of the meiosis? Remember, you've got 2 copies of half the number of chromosomes. Do you want to keep 2 copies in the cell? No. You need only 1 copy of half the number of chromosomes. So what will I do? I will separate those 2 copies. So this secondary oocyte will become an ovum. This is a mature egg. It has only half the number of chromosomes, just 1 copy of half the number of chromosomes. And in order for me to get rid of the other copies that I don't want, so I will be forming another polar body. We call this is the second polar body. So this first one is going to be the first polar body, which makes sense. First one that gets formed, the first polar body. Second one that will be formed is going to be the second polar body. Do I normally have this mature egg if no fertilization takes place? What do you think? If no penetration by sperm takes place? No. The secondary oocytes that will be ovulated will be arrested in metaphase 2. They will not complete meiosis 2. When would they complete them? Second phase of meiosis, once penetrated by sperm. If not penetrated by a sperm, this cell goes through atresia and dies. Degenerated, shrinks, and disappears. So this secondary oocyte, if not penetrated by a sperm again, it degenerates and dies. Easy, easy. So looking at the oogenesis and folliculogenesis side by side. Again, during fetal life, before birth, we've got the oogonium. It's going to be dividing by a mitotic division into primary oocytes. Do I have any mitosis after birth? Can I keep producing more of primary oocytes after I got born as a female? What do you think? Are you able to keep producing primary oocytes after birth? No, you have a limited number, and that's why females will have menopause. Why females have menopause? Simply because over time, over the fertility period, they will be consuming those primary oocytes. So the mitosis here takes place only during fetal life, before birth. How those primary oocytes are going to be kept in the ovary? They are kept in the form of primordial follicles. They are surrounded by one row of squamous cells. Until when? Until puberty. So during infancy and childhood, is there something that is going to be happening here? Nothing. The primary oocytes is going to remain primary oocytes. The primordial follicles is going to remain primordial follicles. There will be no change. All right. Each month from puberty to menopause, what happens? Few of the primordial follicles going to be dividing. Going to be proliferating under the effect of the FSH, if you remember. Primordial follicles will become, some primordial follicles will become primary follicles, that will become secondary follicles, that will become vesicular or Graffian or mature follicles. Only one here that will be formed of the Graffian follicle normally, unless a person is taking medication to enhance the proliferation of the follicles. So normally it should only be one each month. Inside those growing follicles, what kind of eggs do we have? We're still gonna have primary oocytes. We're still gonna have primary oocytes. Once the egg gets penetrated by a sperm, but before it gets penetrated by a sperm, it needs to be released from the Graffian follicle. So the Graffian follicle here is a vesicular follicle. Under the effect of the LH surge, it ruptures and ovulation takes place. Also, in the same time, this LH didn't only stimulate the vesicular follicle or the Graffian follicle, it also stimulated the primary oocyte inside the follicle to complete the first cell division of the meiosis. So this results in what? This results in formation of a secondary oocyte and first polar body. Is this secondary oocyte is a mature follicle? Is a mature egg? I'm sorry. It's not a mature egg. Is this good, Anna? Is this good, Anna? All right. So again, LH surge did stimulate the vesicular follicle to rupture and allow ovulation. In the same time, it did stimulate the primary oocyte to become a secondary oocyte. Remember, in order for me to reduce the number of chromosomes, I would be forming this first polar body. What happens next? After ovulation, you're going to have corpus luteum that will be formed, and as we've seen, it's going to be releasing progesterone. What happens to the egg if there was a penetration by a sperm? This egg is going to be completing the second phase of the meiosis, allowing it to become an ovum, and this will result in the formation of a second polar body. Questions? Anything which is not clear so far? All clear? How do I regulate? The ovarian and menstrual cycles? Remember, the hormonal regulation is taking place first from the hypothalamus. Hypothalamus normally releases GnRH that stimulates the anterior pituitary gland to release FSH and LH. FSH and LH will enhance several follicles to become activated, and they will start to release estrogen. Here, the Griffin follicle or the vesicular follicle are going to be releasing large amounts of estrogen. This high estrogen level is going to have a positive feedback, as we've mentioned earlier. See on here, estrogen will have a positive feedback on the hypothalamus that enhances it to release lots of LH. We call this sudden rise of the LH levels. It's the LH surge, and it takes place on day 14, if you remember. What are the three main effects of LH surge again? If you remember, first one, it enhances the primary oocyte to complete meiosis 1 to become a secondary oocyte. Second effect here is going to be that it triggers ovulation. It triggers the vesicular follicle to release the egg. And the third is going to be it transforms the ruptured follicle into a corpus luteum. Corpus luteum is going to be producing progesterone that will be inhibiting, is going to have a negative feedback effect on the hypothalamus and anterior pituitary gland. And that's why once it degenerates a new cycle will start because I do have drop in both estrogen and progesterone. So the hypothalamus starts to produce GnRH again once it detects that there is a drop in both ovarian hormones. Luteal phase, this phase is going to be taking place during pregnancy when the corpus luteum is going to be producing hormones until the placenta takes over. So remember, I need to maintain the endometrial lining for the baby to be implanted. This diagram is describing what we've already discussed here. GnRH stimulates the anterior pituitary gland to release FSH that stimulates the growing follicles. Those growing follicles are going to be releasing estrogen, and the large amounts of estrogen that will be produced from the mature follicle will have a positive feedback on the hypothalamus and anterior pituitary gland, stimulating the release of large amounts of LH. This is what we call the LH surge. And this LH surge is going to be enhancing the ovulation to take place. The ruptured follicles, those granulosa cells, will be forming the corpus luteum that will release the progesterone that has a negative feedback on the pituitary gland and the hypothalamus. Uterine or menstrual cycle. Remember, we have 3 phases from day 1 to day 4 or 5. This is going to be the menstrual phase. From day 6 to day 14, it's going to be the proliferative phase. Again, those are going to be variable from one person to another. The constant phase that lasts for 14 days, starting from day 15 to day 28, is going to be the secretory or post-ovulatory phase. Remember, menstrual phase is going to be taking place once the ovarian hormones are at their lowest levels. Is this going to result in increase of the gonadotropin levels? Slightly. Stratum functionalis is going to be shedding and the menstrual flow takes place. Proliferative phase, this is going to be taking place when the estrogen levels are high and I am promoting the generation of the new stratum functionalis. The glands going to be enlarged, the spiral arteries will increase in number. In the secretory phase, as we've mentioned, this going to be taking place under the effect of the progesterone. Progesterone levels are high due to the presence of the corpus luteum in the ovary. This is going to be enhancing further development of the endometrial lining, stimulating the glandular secretion and engorging the blood and filling them blood vessels, engorging the blood vessels and filling them with blood. So you see on here, from day 1 to day 4 to 5, this is going to be the menstrual phase, in which I have decline in all ovarian hormones, proliferation of the new follicles, going to be increasing the levels of the estrogen. As you increase the estrogen levels, this will be increasing the thickness of the endometrial lining, because this is the proliferative phase. Proliferative phase is going to be followed by an increase in the glandular secretions, and this takes place under the effect of the progesterone, which that rises due to the presence of the corpus luteum. All right, so what should you talk about in the essay question is all of the above. So starting from the slide, you need to explain the follicular genesis. You need to explain the endometrium, oogenesis, and definitely the hormonal regulation and the 3 phases of the uterine cycle. Yes, you have access to those slides on Canvas, yes. Under Unit 4, you will see the PowerPoint presentations. This is the lecture PowerPoint presentation. So you can break it down into 3 parts. So if you want, you can describe first follicular genesis, the development of the follicles, then the development of the oocytes, oogenesis, then you can describe the menstrual cycle. But before that, you need to, all right, so let's do this here. So before menstrual cycle, definitely you need to describe the hormonal regulation. And finally, going to be this 3 phases of the menstrual cycle. So you can explain each one separately, or you might be willing to integrate all of this together, like the same way that I did go over it. If you want, you can integrate all of this. This is going to be much more confusing when you're writing down. The easier way is going to be for you to describe each of them separately without integration. So you need to explain what is the primordial follicle. You need to explain what is the primary oocyte. All right, so you start here for the oogenesis. You start from an oogonium here. You need to tell me that we are going to have an oogonium and it's going to be passing through a mitotic division, and this takes place during fetal life. Primary oocytes will result from this mitotic division. They will be kept in the ovary and so on. So you need to explain the oogenesis in this sequence. And then if you want to integrate them together, you can do this, but this is more confusing. All right, so you can create a subtopic or another topic in your response to the question, which is the stages of the development of the follicles. And you're going to be describing the primordial follicles that is going to become a primary follicle, secondary follicle, Griffin follicle. Or you can simply integrate everything together like the same way I did in here. All right, those are 2 different ways, but they should deliver the whole picture to the person who's going to be reading your response. All right, any questions? Any questions? Any questions? Yeah, the exam is going to be available on Tuesday for 1 week. So we currently have an exam available. It was available last Tuesday till next Tuesday. And the digestive system and reproductive system lab exam, this will be available this Tuesday to next Monday. All right, so it's going to be available on Tuesday until next month. So you can't have access to the access code. This is the whole idea of proctoring exam. The whole idea of the proctoring exam is that I have the access code on the test, and you need to go through the smarter proctoring in order for you to access this exam. So they are the ones who will write down the access code for you to get into the exam to take the test. For them to make sure that you don't have anything around you, that no face is going to be detected other than your face, that you are the person who's taken the test. So in order for you to access the exam, you need to go through smarter proctoring. You can't go directly to take the exam through Canvas. It's going to be available on Canvas, yes, but once you try to access it through Canvas, it won't allow you because you're going to need an access code, and I'm not going to be providing you with this access code. All right, so I did provide smarter proctoring with the access code for them to open the exam for you to take once you satisfy the requirements. All right, that you are on your own, you have nothing, you have no documents to enforce that you have only one tab open when you are taking the test. You are only using one screen when you're taking the test, and so on. So in order to enforce those regulations on the test, they are the ones who will be proctoring. So they are the ones who will allow you to take the exam. You can't go directly to the exam on Canvas to get it complete. Does this make sense? So in order to get to, see on here, this is Canvas. So when you go to your class, so what class, what time is your class? 9, 1, 1, 2, 3. All right, so this is your class on here. So once you open your course shell on Canvas, one of the choices on the side here is going to be smarter proctoring. And it will be directing you. Make sure you have, and they will be telling you the requirements to take the test before you complete it. So, but you can't even access it through smarter proctoring? Did you schedule the exam or not? Not sure. All right, so let's stay after today's meeting. Just Martina, stay after the meeting, and you can share your screen with me for me to see what's going on exactly on your side. All right. All right, so for now we can have a break for 10. We're gonna come back. We will not be going further to complete the other, the homeostatic imbalances of the reproductive system. This is something that you can read on your own. It's self-explanatory. So just one more diagram we're going to be covering in the reproductive system. And we're going to be moving on to the digestive system to cover all the important diagrams on from the digestive system for you to be ready if you want to start taking the exam on Tuesday. All right. Questions? Other things, so some of you did miss some of the quizzes throughout the semester. So what I will do, I will open up all the quizzes, everything that has been conducted through Canvas. I will open all the quizzes all the exams until the 27th, April 27th. So if you didn't complete any of this, you need to get them completed. All right. They will open all of them for any of you who didn't complete any of them to get them completed. This includes the lecture exams, the online lecture exams. All right. So all of those gonna be open for you to get them complete. If you miss them or you did not get the grades that you want on them. So this excludes the lab exams. This won't apply to the lab exams, only quizzes and lecture exams. All right, any questions? Any questions? All right, so we can have a break for 10. We come back, start our discussion of the digestive system. All right, welcome back, everybody. Can you still hear me? All right, great, great. All right, so another 5 stars diagrams is going to be important for us for this upcoming lab exam is going to be the anatomical structure of the breast. So if we're looking on here, you will see the pectoralis major, and just in front of it, you're going to have those lobules which have the glandular cells of the mammary glands. The mammary glands are arranged into lobules, as you see on here. Each one gonna have its lactiferous duct through which you're gonna be releasing the milk. At the end of each of those lactiferous ducts, we're gonna have the sinuses here. This is called the lactiferous sinus. This is where the milk is gonna be accumulated. And if you remember, when a baby suckles the nipple, the hypothalamus is going to be releasing into the posterior pituitary gland a hormone called oxytocin. And the oxytocin is the one that enhances the smooth muscles of the lactiferous sinuses to contract to allow the milk ejection. Each of those lactiferous sinuses can be connected by a separate duct to the skin surface of the nipple. Surrounding the nipple, we're going to have a pigmented region. We call this is the areola. All right, so again, the structure of the breast, we've got here, those are the mammary glands, and the mammary glands are going to be arranged into lobules. Those lobules are embedded within adipose connective tissue. Each of them gonna have a lactiferous duct, and those lactiferous ducts will be connected to sinuses, lactiferous sinuses. And the lactiferous sinuses, each one of them gonna be connected to the skin of the nipple by another duct that allows it to eject the milk to the outside. Again, this takes place under the effect of the oxytocin released from the hypothalamus through the posterior pituitary gland. Only one homeostatic imbalance I want to discuss its risk factors with you. It's the breast cancer. What are the risk factors for development of breast cancer? If you notice on here, early onset of menstruation and late menopause. So in other words, I have an increase in the fertility period. So if a person got her first menses by the age of 14 and she got her menopause by the age of 45. And another person who got her first menses by the age of 9 and her menopause by the age of 55. So what was the fertility period of the first person and the second person? Fertility period between 14 and 45 is going to be 31 years. And for the second person, she added 15 years to this, like 46 years. So if you notice on here, I've got 15 extra years where this person got exposed to estrogen. And what was the effect of the estrogen on the endometrial lining? Remember, it enhanced the proliferation. It's also going to be enhancing the proliferation of the mammary glands, putting this second person at a greater risk of developing a breast carcinoma. Also, no pregnancies or first pregnancy late in life. Why do you think? Because simply I don't get a break from the estrogen. Remember, during pregnancy, I will keep the corpus luteum for 3 months until its function gets replaced by the placenta. And the placenta is going to be producing a similar hormone similar to the progesterone. So during this time, I have a break for 9 months from high estrogen levels. So having first pregnancy late in life or no pregnancy at all puts a female at a greater risk of developing a breast carcinoma. Breast cancer is also going to be hereditary disease in 10% of the patients. Remember, it's a disease that runs in families. So having a family history of breast cancer puts a person at a great risk of developing a breast carcinoma. Even with those risk factors, we usually have a lot of patients that don't have any of those risk factors. Almost 70% of the women who develop breast cancer, they don't have any known risk factor. Early detection by self-examination. Self-examination is not recommended anymore. What's recommended is a mammography, to perform a mammogram. It's not recommended anymore to perform self-examination. Treatment is going to be depending on the extent of the disease and the type of the disease. And the management plan is going to be different from one patient to another according to the type of the cancer and the extent of the carcinoma. If you notice on here, this is a breast, normal breast, and how it looks like on a mammogram. And this is breast with a cancer that occupies one of the mammary gland lobules. See up here, also occupies some ducts as well. Any questions? Any questions? All right, so what are the important diagrams on here from this chapter that are necessary for you to know to prepare for the upcoming lab exam? We've got here the sagittal section of the male pelvis, showing the anatomical structure of the male reproductive system. This is a 10 stars diagram. A sagittal section of the testis, showing the internal structure of the testis, its coverings, and its connection to the spermatic cord. It's a 5 stars diagram. Another 5 stars diagram would be a diagram showing the relationship between the urinary bladder, the penis, and the different parts of the penis, along with the different glands associated with the male reproductive system and different parts of the urethra. This is a 5 stars diagram. A 10 stars diagram will be showing here a sagittal section of the female pelvis, showing the reproductive organs in females and their relation to the surrounding digestive and urinary organs. This is a 10 stars diagram. Another 10 stars diagram is going to be showing the different parts of the uterus as well as the uterine tubes and the different ligaments attaching those reproductive organs in their place. This is a 10 stars diagram. A 4 stars diagram is going to be the diagram showing the different stages of the follicular genesis and the stages of the maturation of the follicle inside the ovary. This is a 4 stars diagram. Some things that I wanted to focus on in here. Remember that as far as you did not allow this egg to become ovulated, the egg is going to be a primary oocyte. After ovulation, this egg is going to be a secondary oocyte. A 5 stars diagram is a diagram showing the anatomical structure of the breast, the arrangement of the mammary glands, and the relationship to one another and to the surrounding tissues. Questions? All right, so starting today our discussion of the digestive system. The digestive system is going to be divided into 2 main groups of organs. First group of organs is going to be the gastrointestinal tract, starting first from the oral cavity to the part of the pharynx located behind the oral cavity. Can you remind me, what did we call this part of the pharynx located posterior to the oral cavity? part of the pharynx located posterior to the oral cavity. Oropharynx, exactly. And if you remember, the oropharynx is going to be a common pathway for both air and food. It's going to be conducting the food down to the part of the pharynx located posterior to here, posterior to the larynx. So if you remember, this part is called the laryngopharynx. Laryngopharynx will keep conducting the food down to a muscular tube that travels through the diaphragm, where it's going to be conducting the food to a muscular sac. And here, this is the stomach. And the stomach will then conduct the partially digested food. We call it the chyme. Into the small intestines. That will be then conducted to a pouch. We call this as the cecum. The undigested and absorbed part of the food is going to be conducted down from the cecum, or up from the cecum, I'm sorry. So let me increase the length here of the small intestine. So the pouch-like structure of the colon that will be receiving the undigested and absorbed part of the food is what we call the cecum. Cecum will then push the feces up into the part of the colon that travels up. We call this is my ascending colon that flexes and travels horizontally like this. We're going to call this part of the colon the transverse colon. And then it will carry the undigested and absorbed part of the food down. So we're going to call this part, it's the descending colon. Then it's going to be forming an S-shaped segment. This S-shaped segment of the colon is what we're going to call the sigmoid colon. Then we're going to have the straight part of the colon. This is going to be the rectum. That will conduct this undigested and absorbed part of the food to an anal canal and its opening through which you're going to be conducting the feces to the outside of the body. It's the anus. So again, what we're looking at in here, we're looking at the first set of organs that will be sharing in the formation of the digestive system. We've got the oral cavity, then the oropharynx, laryngopharynx, then we've got the esophagus. Down from the esophagus, the food is going to be passing to the stomach. Then from the stomach, it passes to the small intestines. Small intestine is going to be performing most of the absorption, and you're going to be completing the digestion of the ingested food. The remaining parts that failed to get digested and absorbed, it will be conducted from the small intestine to the part of the colon, this pouch-like structure. It's called the cecum. From the cecum, it moves up through the ascending colon that flexes to travel horizontally. This is the transverse colon, and then downwards, descending colon, and then through an S-shaped part. This is the sigmoid colon, and finally through a straight part of the colon is going to be, of the large intestine, is going to be the rectum. That will allow the feces here to travel through the anal canal and to the outside of the body through the anus. All right, this is my gastrointestinal tract organs. Does this mean I'm only fond of those organs? No, you have other accessory digestive organs associated with the tract, other than the gastrointestinal tract. Like what? Like, for example, your teeth, your tongue. That will help you breaking down the food before you swallow. Also, you're gonna have glands, like the salivary glands. We got here 3 pairs of salivary glands. Those are the parotid gland, we've got a set of salivary glands located below the tongue. Those are the lingual or sublingual glands. And we've got a cluster of salivary glands located below the floor of the mouth. Those are called the submandibular glands. Other accessory organs that we have in here, sharing information of the digestive system. The largest gland in the body, this is going to be the liver. And associated with the liver is going to be the gallbladder, which is a muscular sac located on the ventral surface of the liver, in which you're going to be storing and concentrating the bile to get released into your small intestines. Another gland that will be playing a major role in the digestion of the foods that you're ingesting is going to be the pancreas. All right, so again, the digestive system is going to be divided into 2 main sets of organs. We've got the digestive tract. This includes the mouth, pharynx, esophagus, stomach, small and large intestines. Accessory digestive organs, this includes the teeth, tongue, gallbladder, and the digestive glands like the salivary glands, liver, and pancreas. Any difficulty so far? Any problem? All right, so this is a diagram. This is a 4 stars diagram that we have. Basic diagram. So it shows the tongue, the oral cavity, the salivary glands. Again, 3 different salivary groups of salivary glands. We've got the parotid gland on here. We've got the sublingual gland. And we've got the submandibular gland. A muscular tube that will be conducting the food down here from the pharynx towards the stomach. This is the esophagus. This muscular sac located below the diaphragm is going to be the stomach that will be conducting the food to the small intestine that reaches the large intestine. Remember, the pouch-like structure that receives the undigested and absorbed part of the food is going to be the cecum. And the cecum will allow the undigested and absorbed part of the food to travel up through the ascending colon, then through the transverse, then to the descending sigmoid, and finally to the rectum, anal canal, and anus. What are the different digestive processes that will be taking place in the digestive system? First is going to be a function of the oral cavity and mouth. Is going to be ingestion. Can I eat through any other organ other than my mouth? Can you eat through your skin, for example? No. All right, so here it's just a function of the digestive system. It's only an activity that will be conducted by the digestive system. Another important activity of the digestive system is going to be the propulsion. My ability to move the food from the oral cavity all the way to my pharynx, to the esophagus, to the stomach, to the small intestine, to the large intestine, to be released the remaining parts outside by defecation. All this needs propulsion. So the propulsion is going to be taking place throughout the gastrointestinal tract. Also, I will be performing a mechanical digestion. What this means, this simply means I have large particles of bread. If I have a bun here, and I did choose a bun, or I put it in, I did cut it into smaller pieces by a knife. What each of those pieces is, it is still the same bread, or did I have any change in its chemical structure? It's still the same bread. You did cut into smaller pieces, right? So, but what happened is I did reduce the size. We call this a mechanical digestion. But what if I left this bread outside, started to accumulate bacteria on it, I started to break it down, and I will see some fluid leaking from this bread as I kept accumulating this bacteria on it. So now what happened to the bread? It has been broken down into smaller particles on a chemical level. So if you eat a piece of bread, if you put a piece of bread in your mouth and you kept chewing, you will feel that there is some sugary taste that you can have after chewing the bread. What happens in here? Simply, you did not only break down this bread on a mechanical level, you did also break it on a chemical level. It did change the molecular structure of the starch into simple sugars that has into a more simple sugar that has a sugary taste, like glucose. Propulsion, one type of the propulsion for aerial, one type of propulsion is going to be peristalsis. One type of propulsion is going to be the peristalsis. All right, so one of the types of the propulsions that we have in the gastrointestinal tract is going to be peristalsis. After I break down the food on a mechanical level, on a chemical level, I did reach chemicals that are easy enough for my cells to deal with, like glucose, for example, like amino acids. What do I need to do with this glucose and amino acids? I will absorb them. So I'm taking all of them from my lumen, from my intestinal lumen to my blood vessels. I'm allowing here the absorption to take place. All right. What would I do with the part of the foods that I'm taking that won't be broken down or that I don't have receptors for it to be absorbed? So I can't absorb it. It's small enough, but still can get absorbed. So all this remaining part of the foods that you're eating that fail to be broken down, digested, or to be absorbed, it's gonna be released to the outside by defecation. So again, what are the main activities of the digestive system? First is ingestion. You're gonna be performing mechanical digestion, like chewing that takes place in your oral cavity, like churning that takes place in your stomach, and like segmentation that takes place in your small intestines. What is a segmentation? It's a type of propulsion here. You see, I'm contracting the circular muscles. And when you contract the circular muscles, you're going to be dividing the tube into smaller segments that will allow you to break down the food particles into smaller sized particles, allowing you to perform a mechanical digestion. This is a segmentation here. Segmentation is a mechanical digestion that takes place in the small intestine. Allowing propulsion. Propulsion includes swallowing, your ability to move the food from your oral cavity all the way down to the stomach. Then we've got the peristalsis that will be taking place in the stomach, small intestine, large intestine. This is going to be the propulsion. Also, I will need to perform a chemical digestion. I need to change the molecular structure of the food I'm eating. to get the molecular form that my cells can deal with. So where do you start the chemical digestion? Chemical digestion starts in your oral cavity under the effect of the salivary gland secretions. It's gonna be partially completed in your stomach under the effect of the hydrochloric acid and the other gastric enzymes. It will be finalized and completed in the small intestine under the effect of the bile that gets released from the liver, under the effect of the pancreatic secretions, and under the effect of the enzymes released from the small intestine itself. We call them the brush border enzymes. So here in the small intestine, we're gonna be finalizing the chemical digestion. What would we need to do after we completely break down those food particles mechanically and chemically? We need to absorb them. Most of the absorption is going to be taking place in the small intestine. Most of the nutrients are going to be absorbed from the small intestinal lumen to the blood or the lymphatic vessels if I am dealing with fats. But the absorption is not only taking place in the small intestine. Yes, most of it takes place in the small intestine, but part of the absorption can also be taking place in the large intestine. What would I absorb in the large intestine? Large intestine is going to be absorbing water and vitamins. Water. If a person didn't absorb the water because of inflammation of the mucosal lining of the large intestine, for example, he will develop diarrhea. If he has slow contraction, slow peristalsis of the large intestine, so those feces gonna remain for longer time in his large intestine, making it even more difficult for him to move the feces out, and I can develop fecal stones because of the extra absorption of the water. Why would I wait all this time to absorb those vitamins? Why I didn't absorb them in the small intestine? I did have all the small intestine to absorb those vitamins. Why would I absorb them in the large intestine? Because simply I didn't have them. Some of those vitamins are going to be actually produced by the bacteria, flora living in the large intestine. So the bacteria will be breaking down the undigested and absorbed part of the food that reaches the large intestine, and as a byproduct of the bacterial metabolism, they will be producing some vitamins that get absorbed from the large intestine. Questions? All right, so looking here at another important diagram for us, it's a 4 stars diagram. It's showing how the digestive organs are going to be kept in the abdominal cavity. If you see on here, the abdominal organs are going to be surrounded by a serous membrane, and this serous membrane is called the peritoneum. The peritoneum has two membrane layers. A layer that will be directly attached to the wall of the organs, and another layer that will be lining the abdominal cavity from inside. Like the pericardium, like the pleura, we have a visceral layer, we've got a parietal layer. But the difference here between the peritoneum and the pericardium and the pleura, I have here inside the peritoneal cavity, you've got multiple organs, not a single organ in the cavity. So those organs are going to be attached to one another by parts of the peritoneum. We call those parts are my mesenteries. So you've got a dorsal mesentery that will be connecting the organ to the posterior abdominal wall. And we've got the ventral mesenteries that will be connecting the organ to other organs and the organs to the anterior abdominal wall. Looking here at the structure, internal structure of the gastrointestinal tract, the different layers of the gastrointestinal tract. General structure, we've got an innermost layer. This is called the mucosa. Underneath the mucosa, we've got the submucosa. To the outside of the submucosa, you've got the muscle layers on here. This is my muscularis externa, or another name for it is musculosa. The outer layer that I have covering the musculosa from outside, this is my serosa. So again, 4 layers forming the wall of the gastrointestinal tract. From inside out, you've got mucosa. You've got to the outside of it submucosa. Surrounding the submucosa, located even more towards the outside of the submucosa, deeper to the submucosa, is going to be the muscle layer. We call it the muscularis externa. And to the outside of the muscularis externa, or musculosa, we've got a thin layer of connective tissue and epithelium. That's going to be my serosa. Mucosa is going to be formed of epithelial lining. Remember, what is the type of epithelium that we've got lining the gastrointestinal tract? Do you remember what type of epithelium is lining the gastrointestinal tract? Simple squamous, any other? Columnar, columnar. Columnar. What else? Any other? Any other? So it's according to what part? It's according to what part? So simple squamous is not going to be lining the gastrointestinal tract. It's so delicate. It won't have it won't act as a strong barrier. So I can't have simple squamous. I don't also have cuboidal. But I have, if you remember, the parts that are directly exposed to the outside, they need a greater protection. So what are the parts that will be directly connected to the outside? Those are going to be the oral cavity, pharynx, and the esophagus. Those parts going to have stratified squamous epithelium. But remember, you didn't need the highest level of protection. Where do you need the highest level of protection in your body? In your skin. So your skin did have an epidermis formed of keratinized stratified squamous epithelium. Here's the oral cavity, the pharynx, the esophagus don't have a keratin layer. So they are lined with non-keratinized stratified squamous epithelium. Compared to the rest of the gastrointestinal tract, stomach, small and large intestine, all those going to be lined with one row of columnar cells. Simple columnar epithelium. Do I need to have cilia here to allow the movement? No, you're moving huge structures. Cilia can't move those large structures. You rely on muscle contraction to allow the movement. So it will not be ciliated. It will be a non-ciliated simple columnar epithelium. What was form of ciliated simple columnar epithelium? Where did I have ciliated simple columnar epithelium? It was here in the fallopian tubes. This is where I did have simple columnar, which is ciliated, because I'm moving one cell here. I'm moving one cell, the fertilized egg that can't move on its own. So I need to move it towards the endometrial cavity. But here I don't have cilia. Cilia won't be playing any role in the movement of the food. Food particles are much larger in size. They can't move by the cilia of an epithelium. So what kind of epithelium again is lining the gastrointestinal tract? That would be the innermost layer and the most superficial layer of the mucosa here. This is going to be, again, according to the location. You're looking at oral cavity, looking at pharynx, esophagus. It's going to be non-keratinized stratified squamous epithelium. If I'm looking at stomach, small intestine, large intestine, this is going to be non-ciliated simple columnar epithelium. All right, so when I show you a slide on the test having an epithelium and I ask you where is it located, and I give you a list of choices, if it was stratified squamous epithelium, which is non-keratinized, you should be checking for oral cavity, pharynx, or esophagus. You're going to have a list. Well, only one of them is going to be present on the list. This is going to be your answer. This is how I create this those questions. Or I will show you this part and will tell you what is the epithelial lining. So I will have keratinized, I will have non-keratinized, I will have ciliated and non-ciliated in the choices. The most common wrong answers that I will see is people selecting ciliated epithelium, ciliated columnar, simple columnar, because they think that cilia have a role in the movement of the food. This is the impression that you get when you hear ciliated. Yes, it makes sense. Actually, it doesn't. Doesn't make sense here. The cilia won't be able to move the food particles. Food particles are much larger in size, beyond the cilia ability to move. Questions? Make sense? All right, so again, what is the type of epithelial linings that I have in here? Oral cavity, pharynx, esophagus, non-keratinized stratified squamous epithelium. Rest of the gastrointestinal tract is going to be non-ciliated simple columnar epithelium. Five stars diagram that we've seen most of the structures that will be appearing on here. We've seen them back when we studied the upper respiratory system. Remember, this will be the hard palate. Here is going to be the soft palate. And don't confuse the uvula with the soft palate. Uvula is this part that is pending down. On both sides, we've got here, this is the palatine tonsil. Palatine tonsil. We've got a tonsil here at the base of the tongue. It's going to be the lingual tonsil. And this is going to be the tongue. The part of the pharynx located posterior to the oral cavities, this is the oropharynx. You kept moving down. The part of the pharynx located posterior to the larynx, this is my laryngopharynx. In front of it, you're going to have the larynx. It has an epiglottis, thyroid cartilage, and cricoid cartilage, if you remember from the previous chapters. Inside, you've got the vocal cords. Inside, you've got the vocal cords, but the whole thing is the larynx. If I'm pointing to the whole thing, it's going to be the larynx. If I'm just pointing to the fold here, it's going to be the vocal cord or the vocal folds. An anterior view of the oral cavity, what you see on here, this is going to be the palatine raphe of the hard palate. The posterior part is going to be the soft palate. And the pending part from the soft palate is going to be the uvula. If we're looking here, this is going to be the tongue. The tongue is going to be attached by the lingual frenulum. And on both sides of the lingual frenulum, we've got the openings of the salivary glands. We've got two large openings. Those are the openings of the submandibular glands. And the smaller openings on the sides located away from the midline and away from the lingual frenulum. Those are the openings of the sublingual ducts. What are the sublingual and submandibular glands? Those are two types of salivary glands. If we're looking on here, three pairs of salivary glands. We've got the first one, this is the parotid gland. It's going to be conducting its salivary secretions through the parotid duct. Be located below the tongue. We've got here, this is the sublingual gland, and underneath the floor of the mouth, this is going to be my submandibular gland. So we're looking on here, back to our diagrams. This is a 5 stars diagram. 5 stars diagram. We're looking on here. Upper lip, lower lip are going to be attached to the mucosa that covers the maxillary bone and the mandible. We call the attachment here between the upper lip and the maxillary bone and the lower lip and the mandible. Those are my lingual frenulae. Lingual frenulae. I'm sorry, labial frenulum. Labial frenulum. So lingual frenulum is the attachment of the tongue. Lingual is tongue. Labial means related to lips. So I've got lingual frenulum, the attachment of the tongue to the floor of the mouth, and the frenulae here that will be attaching the lips to the mucosal covering of the maxillary bone and the mandible. Those are my labial frenulae. All right, for the question here from Happy. So for the different layers, yes, you need to know the different names of the 4 layers. We don't need to know the different substructures in those layers for now. On this diagram, this is another 5 stars diagram. The main important things that you need to know on this diagram are the 4 layers: mucosa, submucosa, muscularis externa, and the serosa. Those are the 3 main things, the 4 main things that you need to identify on this diagram. This is the 5 stars diagram. The sagittal section here showing the structures of the oral cavity from a side view. This is another 5 stars diagram. Another 5 stars diagram. Most of the information on this diagram has already been covered in the upper respiratory system diagram. So nothing new on here. This is another 5 stars diagram. Everything is going to be easy to remember. The only things that might be confusing is going to be those arches. So you've got 2 arches on here, one in the front, one in the back. The one in the front, if you see, it connects the hard palate to the tongue. So we're going to call this is my, or it's connecting the hard palate to the pharynx on here. This is going to be the hard palate to the tongue first and then to the pharynx. So the anterior one is going to be the palatoglossal, and the posterior